Hi again. I would like to talk about putting radicals into equations and solving for x or whatever. Let's see how that's done. Oh, in the distance I see my friend Euclid coming here. Listen, he wants to remind us of something. Okay, let me get out of the road here. He wants to remind us that if you take like the square root of x times the square root of x, you just get x. Notice you have the same variable under each one of those radicals. We can use that idea. Okay, so let's look at our first problem. Actually, we can use it directly. The square root of x equals 4. The trick is we need to square both sides. Now, what happens when you square the left-hand side? You're multiplying the square root of x times the square root of x, and as Euclid said, that just gives us x. And of course, 4 squared is 16, so we get x equals 16. Now, this problem here can't be done because you can't take the square root of number and get a negative answer. So there's no solution. So watch out for that. So the next problem here, we'll work it like we did the first problem here. Let's square both sides. So when we square the square root of 3x minus 2, that will just become 3x minus 2, and the right hand side will become 25. And we want to add 2 to both sides, and so we'll get 3x equals 27, or x equals 9 in this case here. So let's see what surprises we have here next. Now this one here, you need to get the square root on a side by itself. So let's take and add 12 to both sides. So there we have it. Now let's take and square both sides like we've been doing, and so the left hand side will just become 3x plus 9, and the right hand side will become 144. Now let's take and subtract 9 from both sides, and we'll get 3x equals 135, and finally x will equal 45. Next problem here, a little bit different. We have a square root on both sides. So just go ahead and do as we've been doing. Let's square both sides. And so that's just going to get rid of all the radical signs, and we'll get 4x minus 2 equals 3x plus 9. Now let's subtract 3x from both sides, and then we can add 2 to both sides, and we'll get x equals 11. So once we get through this, getting rid of the radical sign is just working an equation out. Now this one, we're going to have to work a little bit harder. What we need to do is take that square root of x and move it to the right hand side. So we'll subtract off the square root of x. Now on the left hand, now we'll go ahead and square both the left hand side and the right hand side. And the left hand side is easy. It's just going to give us x minus 5. But the right hand side, we're going to get 5 minus the square root of x times 5 minus the square root of x. It's like 2 binomials. And you'll get use that FOIL method, and you'll get 25 minus 10 times the square root of x plus x. Now the x's will disappear, and we can add 5 to both sides, divide through by 10, square both sides, and we'll eventually get here x equals 9 is our answer. Now the last problem is a little different, and then it's a cube root. Now we can attack this the same sort of way, but this time we're going to cube both sides instead of squaring both sides, and that will remove the radical on the left hand side. So we get x minus 2 equals 3 cubed, and then we want to add 2 to both sides here, and we'll get an answer of x equals 29. Thank you.